So hello guys, welcome to Perfect Electrical Solutions. Today we are discuss about CRO cathode ray oscilloscope. So now we are seeing on our display it says CRO. In CRO having a many buttons. These are the push buttons and this is your knobs and this is your CRO display and this is the display which shows the value set by us through this channel. Okay. So first of all, this is your on off switch of CRO and this point will be used for maximum voltage or signal to 10 times. So it's mean we can magnify the signal of x axis to 10 times, and second one is used for merging the x and y, and this point is used for channel selection. Now I am press this button and the waves are gone from the display. That's mean now it's CRO switch on to the second channel. Now it's on first channel. This switch are used for using both channel. Okay. So this is your external setting. For this external setting, this is for auto level setting. So next one is your, so this knob is used for shifting x-axis like this, and this knob is used for shifting y-axis of 1. That means we can shift the y-axis of channel 1, and this knob is used for shifting y-axis for channel 2. Okay, so we can change the voltage level of the channel 1 with the help of this knob. See, in the CRO display, the amplitude of the wave will change when I move this knob to 5 volt from 10 volt. Okay, and this is for channel 2, and this is your time division. With the help of time division, we can see the frequency because we divided a seconds in millisecond to microsecond, okay, to nanosecond. Okay, so here is your terminal which is used for when we are measuring a circuit or measuring a signal in AC supply or in DC supply. Okay, this is your channel 1 input port and this is your channel 2 output port. This point is used for focusing the signal. Now we are seeing the thickness of the signal, it's increase and it's look like a rough signal, and when I decrease the focusing of the signal, the signal become a sharper, and this is the intensity port, make a visible or invisible of the signal. Okay. So now we are discuss about the function generator. In this function generator, we are seeing having a 5 knobs. This is 1, 2nd, 3rd, 4th and 5th knob. First knob is used for fine variation when we are want to increase or decrease the value in small point or small level, and this knob is used for frequency variation. Okay, and this knob is used for selecting the range, which is used for setting a frequency in kilohertz, hertz and megahertz. Okay, like this. Now the value is shown in the display is 35 kilohertz. Okay, and this is your functioning knob, means which can used for changing the signal from sinusoidal to triangular and triangular to square. Same this signal we can check on the CRO. CRO shows sinusoidal wave and the input given to the CRO from the function generator is sinusoidal. When I change the signal function from sinusoidal to triangular wave, the output on the CRO, it will also change. And if I change this function from triangular to square wave, and now we can see the wave shape change from triangular to square wave. Okay. So the fifth knob of function generator is level. It's mean we can change the amplitude of the signal from this level. In simple word, we can change the voltage range peak to peak of the signal with the help of this knob. If we rotate this knob is in anti-clockwise direction, that's mean the voltage of the function peak to peak become decrease. If we rotate this knob in clockwise direction, that's mean the voltage of function or signal it will be increase. Now we are going to discuss most important things about CRO. According to this function generator, now we are providing a 35 kilohertz frequency to this CRO. That's mean the frequency complete a 35 kilohertz cycle per second, and we set the time division 0.25 second, means 1/4 per second time division set by us for seeing the wave shape, and the 35 kilohertz cycle are moved in this line. For making this signal visible, we can change the time division to second to millisecond. Okay. Now we are set the time division is 0.1 millisecond, and this signal is visible to the screen, and signal is visible to the CRO graph.
So this is the observation table which we need to fill while we are performing the CRO experiment. In the first column we need to put the function which way we are used. That's mean if we are using a sinusoidal wave, that time we need to put here sinusoidal. This is vertical division. That's mean how much the division covered by a signal in vertical position. This is voltage per division. That's mean voltage per division set by us on CRO. And third one is your amplitude peak to peak. V is equal to A multiplying B. So next is your horizontal division. That's mean how much the horizontal lines or division covered by a signal. The count of this division we need to put here. And next one is time division. Time division set by us on CRO. We need to fill there. And next is we calculate the time. T is equal to C into D, horizontal division, multiplying by time per division. And next one is frequency. We know frequency is a inversely proportional to time.
So now we are going to fill the observation table. So we are using a channel 1 for input in CRO from function generator. So this is the voltage per division set on channel 1 is 10 volt. So this is the observation table, and this is the value set on CRO. First of all, in function we need to write a sine wave. So I'm write here sine wave, and vertical division covered by the signal. So one box is your one division, second box is your second division, and the which signal we are giving to the CRO, it is cover the peak to peak one division. So I'm write there 1, and voltage per division set by us on CRO is CH 10 volt. So I'm write there 10. So the amplitude is peak to peak of this signal is equal to 1 into 10 is equal to 10 volt. Okay. So next is your horizontal division. When we are going to calculate the horizontal division, in horizontal division we calculate a one cycle. In one cycle having a one positive alternation and one negative alternation like this. This is your one cycle. So I am adjusting the wave from this knob like this for measuring the now see there this wave starting from 0 on our origin point to from this is its positive cycle and this one its negative cycle. So in horizontally direction this waves not complete a one division, so we are now going to a subdivision of the signal 0.8. How I calculate 0.8? The division of one box, it's already subdivided into 5 point. So I divided 1 divided by 5. So one subdivision it's become 0.2 and this signal covers the 4 subdivision of the box. So that's mean horizontal division covered by this signal is 0.8 and the time division is 0.1 millisecond. So I am writing in my observation time division is 0.1 millisecond and we can calculate the time from multiplying by C and D and the frequency is inversely proportional to time. So today we are completed the experiment CRO and function generator. If anyone having any doubts, please comment on the comment section and write your valuable review. Thank you so much.